This is section 7.4, and we're going to be dealing with identities. And so there are, in the Trig identity packet of formulas, you may want to go ahead and grab that and be having that as a reference, but I've put several here that are needed. Quotient identities, these two are pretty common. Tan theta is equal to sine over cosine. Cotan is equal to cosine over sine. These are things that you actually need to just learn. And here's some more. Reciprocal identities. These are where cosecant is equal to 1 over sine, or vice versa. Sine would be equal to 1 over cosecant. Secant, 1 over cosine, and cotan, 1 over tan. The Pythagorean identities look like this, and there are 3 of them. This is the most commonly used one. Sine squared theta plus cosine squared theta equals 1. And then we have the tan squared and secant squared, the cotan squared and the cosecant squared. And then we have some even odd identities. So if we're working with identities, the guidelines here talk about that it's almost always preferable to start with the side that contains the more complicated expression. Sometimes you'll rewrite sums or differences of quotients as a single quotient, so make it one fraction. Sometimes you'll change things to sine and cosine, that helps. But always keep the goal in mind. As you manipulate or change one side, keep in mind the form of the other because you're trying to make them be equal. Sometimes you can use algebra to simplify things. So you have to remember about multiplying numerator and denominator by a ratio of a well-chosen one, writing sums as a single ratio, factoring, different things. So let's look at a couple of these. So if we were given, and this is the way I do them, if you have another way, that's fine. But when I do it, I work on the more complicated side, and when I finish, I want to end up with this side, and I usually circle both of them and connect them, saying, yes, they are the same. So cosecant theta times tan theta equals secant theta. Well, we got a lot of different stuff, but let's try changing all of this to sines and cosines. This one is 1 over sine. This one is sine over cosine. Since we're multiplying, the sines can cancel out. We're left with 1 over cosine. That is in turn equal to secant, and we've accomplished our goal. Let's go to this one. 1 plus tan x over 1 plus cotan x equals tan x. So obviously we're going to work on this side. We've got this cotan here. We know we want to end up as tan, so let's change this cotan to 1 over tan. So I did that in this step. Then I made this on the bottom one fraction. So I changed 1 to tan over tan, and then I've got plus 1 over tan. So that whole thing became this. Then I said, okay, I've got this over a fraction. I'm going to make it be this term, 1 plus tan x over 1 times, I'm going to flip this one, and I have tan x over tan x plus 1. Well, those are the same, and so I'm left with tan x, which is what I was trying to get to. The more you do of these, the better you'll be, and they're all different, so you just have to get used to the strategies. All right, so we've got in parentheses tan theta plus cotan theta times sine theta, and we want to end up as secant. So I think over here we're going to put things in terms of sine and cosine. So tan is sine over cosine, cotan is cosine over sine, and we're multiplying times sine. So I'm going to go ahead and change these two fractions. I'm going to go ahead and combine them. The common denominator would be cosine sine. If you divide cosine into this denominator, you get sine. Multiply it by this numerator, you get sine squared. Sine divides into this and it leaves cosine. Multiply times the numerator, you get cosine squared. So this is what I have times sine. That is on the top, that's on the bottom, those are gone. So now I have sine squared theta plus cosine squared theta over cosine theta. Well, this is a Pythagorean identity, and it's equal to 1. So now I have 1 over cosine theta. That's equal to secant theta, and that is what I was trying to get. So think that gives you an example of what we're doing, and now we're going to go look at our problems. All right, number 1, state whether this is true or false. Sine squared theta equals 1 minus cosine squared theta. That is true because the identity says sine squared theta plus cosine squared theta equals 1. So have your identity sheet really close to you so that you can reference it while you do these. So that's a true. Complete the following equation. Tan squared theta minus secant squared theta equals. Well, this is the identity that we know. If I subtract the secant squared theta over here, because that's what's happening, then I subtract that over there, that gives me my answer. This piece here is equal to -1. Okay. Which of the following is not an identity? Well, we know that that is 1. That's one of the odd identities. Cosecant theta is equal to 1 over sine. Tan is not equal to cosine over sine, so that is not an identity. Rewrite secant theta over tan theta in terms of sine and cosine. That means we can't have anything other than sine or cosine in our answer. So secant theta is 1 over cosine theta. Tan theta is sine over cosine. So we're going to put that 1 over cosine over sine over cosine. We're going to flip this one and multiply. So we have 1 over cosine theta times cosine theta over sine theta. Cancel. You're left with 1 over sine theta. And we don't go any further because we're supposed to leave it in terms of sine. That is equal to cosecant, but we don't want to go that far. We have to leave it in this. All right, multiply the following expression by following the indicated direction. So it says take this and multiply by this. So I wrote down cosine theta over sine theta minus 1 times, and that's what they told me to multiply. Now, if we do that, on the top, we've got cosine theta times sine theta plus 1. And then we've got sine squared theta minus 1. That's like foiling that, all right? So if we think about it, cosine squared is equal to 1 minus sine squared theta. If I manipulate that Pythagorean identity and subtract that sine squared, so that's what that's equal to. And so I've got the opposite of that. I've got sine squared theta minus 1. So that's equal to negative cosine squared theta. So I write that there. Since I have a cosine theta here and a negative cosine squared theta here, one of those is gone and I'm left with a negative cosine theta on the bottom. And that negative can come out front, so I'm left with negative sine theta plus 1 over cosine theta. That's what should go in your box. Number 6, I simplify this expression. So if I multiply these two, that I'm not going to have a middle term. I'm going to have 1 minus cotan squared theta, and then I have a minus cosecant squared theta. Well, cosecant squared theta, let's look back at our notes. Cosecant squared theta is equal to cotan squared theta plus 1. So I'm going to substitute that in there, but I have a minus. When it comes out of the parentheses, I now have minus cotan squared theta minus 1. The 1's cancel each other out, and I'm left with -2 cotan squared theta. Number 7, multiply and simplify. So we've got this on top, this on the bottom. All right. So up here, I'm going to go ahead and multiply these, which gives me cosine squared theta minus 2 of those if you're doing FOIL, plus sine squared theta, and then I have a minus 1. All right? Well, we should always see that if we have a cosine squared and a sine squared and they can be added, that's equal to 1. So those two things there become 1. Then I have a minus 1, and I have a minus 2 of those over that. Well, the 1's cancel each other out. I've got negative 2 times that over that. Those cancel out. I'm just left with negative 2. All right. Number 8, establish the identity. So we've got this left thing equal to 1. If I multiply this, I get secant squared theta minus tan squared theta equals 1. Why does that work? Well, if we go back here, what kind of identities are those? Those are Pythagorean. And it's asking you, what lets you do what you're doing? Because that is, 1 will be equal to 1. Pythagorean right there. Number 9, establish that. So they have you do it in steps. Rewrite the left side by expanding the product. So that means you're going to distribute. So I have cosine squared theta plus tan squared theta cosine. That goes in that box. Apply the appropriate quotient identity and or appropriate reciprocal identity. Well, tan squared is sine squared over cosine squared theta. That goes in that parentheses. Simplify that by canceling the common factors. All right? So what happens? Cosine squared and cosine squared, those cancel out. And now I just have cosine squared theta plus sine squared theta. And then that simplifies to 1 using what? That's a Pythagorean. We'll just choose that. Number 10, we're doing the same thing. We're doing it in steps. So we have this. It says establish the identity. Write the left side in terms of sine and cosine. So tan becomes sine over cosine. Secant becomes 1 over cosine. Simplify by writing that with a common denominator. So if it's all over cosine u, that'll be sine u minus 1. That's just the top. Rewrite that by multiplying the numerator and denominator by sine u plus 1. Sine u plus 1. If I multiply that by the top, I'm going to have sine squared u minus 1 because I'm multiplying this times this. Write the numerator in terms of cosine. Well, sine squared minus 1 is equal to negative cosine squared. All right, the fraction simplifies to cosine u over 1 plus sine u using what? Cancellation property, because that cosine divided into that one and left 1 up there. Okay, I think that's it. I think we had 10. So that gives you some practice working with identities.